Okay guys, let us begin our video tutorial about DC generator, no? So ito yung pinaka basic formula or mostly used formula sa ating topic na DC generator. Ang unang-una dyan ay yung generated voltage is equivalent to P zone over 60A. Binansagan ko lang siyang P zone para hindi ko makalimutan or mas madaling tandaan, no? Where P is equivalent to number of poles, G is equivalent to number of elements or conductors, then Cp is equivalent to flux per pole, and ang unit niya ay Weber. Then si N is number of turns or rotation, units niya RPM. Then A is ay si parallel path, na. Tatanda natin kay A, for lap wound, A is equivalent to M multiplied by P, where M is a multiplier. Siya yung nagdi-describe kay generator kung siya ay simplex, duplex, triplex, quadruplex, na. Then si P stands for number of poles. For wave wound naman, A is equivalent to 2M, then si M ay yung multiplier, na. Notes natin ay 1 Weber is equivalent to 10 to the 8 Maxwell or lines. Meron tayong types ng generator. Ang unang type ay ito, shunt generator or shunt wound generator, na. Ito yung equivalent circuit nya, where this is the generated voltage dito, and then si RA, R shunt, tapos yung si terminal voltage dito, or voltage load. Then ang current flow nya ay si IA, IL, then si I shunt. Then ang formula natin doon ay IA is equivalent to I shunt plus IL. Then si IL ay equivalent to PL over BL, or yung power ni load divided by voltage load. Then si I shunt ay B shunt over R shunt. Then ang tatandaan natin dito, si V shunt at si voltage load ay equal lang, na. Then si generated voltage ay equivalent kay voltage load, ito yon, plus armature voltage, na. Dito yon, si armature voltage ay armature current multiply by armature resistance. So kung titingnan natin maigi, ito generated voltage is equivalent to voltage load plus IARA, na. Then si series generator ay ito naman, ito RA, ito yung kay generated voltage natin dito, na, kay si generator, kasi voltage load or terminal, na. EG is equivalent to voltage load plus VA, where VA is IARA, na. Then ito pa, meron tayong other two types, short shunt generator tsaka si long shunt generator. Ang tatanda lang natin, ang pinagkaiba nila kay shunt generator, long shunt generator, tapos short shunt generator ay meron silang series field resistance, stands for RSE. Tatandaan natin, pag long shunt, letter L nagsisimula si long, so dapat si RSE nasa left, na. Pag short shunt, automatic sa right. Pag left, si long left agad dyan ang series field, na. Isa tayo kay short shunt. Ito yung equivalent circuit ni short shunt. Dito yung kay generated voltage, then si armature resistance, shunt resistance, na. Then ito si series field resistance, na. Ito si terminal voltage, where ito si IA, I shunt plus si IL, na. Dito VL is not equivalent to V shunt dahil may voltage drop tayo kay series field, na. So V shunt is equivalent to series field voltage plus voltage load, na. V shunt is equivalent to IL multiply by RAC, ano lang yan, simpleng ohms law lang, na. plus voltage load. Okay? So, para makuha si V shunt, I shunt multiply by R shunt, then si I shunt naman, V shunt over R shunt. Para makuha naman natin si IA is equivalent to IL plus I shunt. Then si EG, IVA plus V shunt. No? Si VA ay halos the same lang. Paikot, ganun lang din yung formula niya. IARA. Then si V shunt, ito. IL, REC kasi voltage drop dito plus voltage load. No? Then si power generated by generator, yan na, si EGIA. No? Where EG is, ito yung formula. Papasok mo lang dito, ayun na. No? Then kay long shunt naman, kay long shunt generator, nasa left si RSC. Then dito, ito si EG ulit, si RA, RSE, RSH, VL. No? Ito si IA, IL, I shunt. Where IA is equivalent to I shunt plus IL. Dito lang, I shunt plus IL, ayun na yung armature current. Then, si V shunt, kay long shunt generator ay equal na siya kay VL kasi wala na tayong series field resistance dito na nagkakos ng voltage drop. So, equal na yung voltage dito, then voltage dito. Then, EG is equivalent to, or generated voltage equivalent to VA plus series voltage plus V shunt. Where VA is IA multiplied by RA. Then, si VSC ay IA multiplied by RSE. Then, V shunt is equivalent to voltage load, or pag hindi given, I shunt, R shunt. Then ang formula pa rin ni power generated ay EGIA, no? Ito yung mga importante sa DC gen, ang power flow, no? Where power input, power generated by generator yan, ha. Then power output, SPL or stray power losses. Then PCU is equivalent to copper losses. Hati natin sa dalawang part si power flow, no? Where ito electrical efficiency, then ito si mechanical efficiency, no? Electrical efficiency is equivalent to power output divided by power generated, or PG na lang, na times 100, na. Then kay mechanical efficiency ay power generated over power input times 100, na. Ayun na yun. Then si overall efficiency or commercial efficiency is equivalent to P out over P in, where P in is equivalent to ito, power output plus power losses, where power losses is equivalent to SPL plus PCU or copper losses. Ito siya, no? Ito si stray power losses. Then si PCU ay copper losses. Pag shunt generator, kadalasan ang copper losses natin ay ito, si armature, yung RA yan, yung power na na-absorb ni RA, then yung power kay I shunt, no? So kung iano natin yung overall efficiency natin, power output, then si power input, ito power output plus power losses, no, ay ito, power output plus PCU or copper losses plus SPL. Di ba? Madali lang. Kaya. So di kayo mahirapan yan pag nagkataon, no? Then ito pa pala. Para makuha si power generated, no? PCU or copper losses plus power output lang. Okay? Then para makuha si power input ay power generated plus SPL na para makuha lang yung mga hinahanap. Then si power input ay equivalent to SPL plus PCU or power PA plus P shunt plus power output na. Tapos pala may nakalimutan ako dito kay long shunt at kay short shunt generator. Pag sinabi, may kadalasan kasi may sinasabing diverting winding, no? Pag sinabing diverting, ay kay short pala dito, short shunt. Pag sinabing diverting ay may naka-parallel kay series field, no? Meron tayong naka-parallel dito na resistor pag sinabing diverting. Tapos pag sinabi namang interpole, meron tayong naka-series kay RA, no? So note lang natin, diverting is equivalent to parallel with RSC. Then si commutating or interpole ay equal dyan ay naka-series kay RA na. So ayan lang notes natin about kay DC generator. Let's move na lang sa sample problem. Okay, ito, tignan natin maigi lahat ng formula. Simulan natin sa simula. This one, ito. Ayan, lahat ng formula ang ginamit ko. Then this one, take down notes nyo na lang, no? Ito, ayan. So, ayan, no? Naintindi na masulat ko. So, let's start our sample problem about DC generator, no? So, a 4-pole DC machine is wound duplex lap. Find the number of parallel paths. So, solution natin. Okay? Solution. Ang sabi niya, meron tayong 4-pole wound duplex lap. Duplex. Tapos lap pa siya. So, ano ba hinahanap? Parallel paths. So, hinahanap si A. So, for parallel paths, kapag lap winding siya, A is equivalent to MP. So, ang solution lang natin dyan ay, ano ba P natin? Ay yung M natin, duplex. So, 2 multiply by number of poles, 4. Meron tayong 8 parallel paths, no? Then, if the armature of an 8-pole machine were wound with a simplex wave winding, how many parallel path would be there? No, meron tayong 8-pole wound with simplex. So multiplier niya 1 lang kasi simplex, di ba? Okay? Tapos wave winding. How many parallel path would be there? No, parallel path ang hinanap. So letter A ulit. Di ba pag wave, yung parallel path natin is equivalent to 2M. So 2 times multiplier natin ay 1 kasi simplex lang. So 2 times 1 is equivalent to. Meron tayong 2 parallel paths. Then sa number 3, an 8-pole DC machine has a simplex wave wound armature with a current rating of 110 amperes. Determine the current per path. So meron tayong 8-pole simplex wave na ano ba hinahal dito? Current per path, no? So meron tayong armature current na 110 amperes, no? Ang gagamitan natin, ang hinahanap sa kanya per path, no? So yung A natin ay yung path, parallel path. Para makuha natin yon, ba siya? Wave wound. So 2M, 2 times M, no? Ano ba siya? Simplex. So times 2 times 1 lang. So A natin ay 2, yung parallel paths natin. Pag ganyan, pag current per path, no? Meron tayong armature current is equivalent to current per path multiply by A, na? So meron tayong 110 amperes multiply by current per path, no? Times 2. Then current per path natin ay 55 ampere. What is the average, number 4? What is the average voltage generated in a moving conductor if it cuts 2.5 times 10 to the 6 Maxwell in 1/40 second, no? So meron tayong formula na voltage average, no? Ay equivalent ng flux over time, no? So meron tayong flux over time, no? Meron given tayong flux, meron tayong given 2.5 times 10 to the 6, no? Maxwell over 1/40 seconds. Okay? Dapat ang flux natin lagi ay naka Weber. So multiply ba natin yan? Di ba may notes tayo na 1 Weber is equivalent to 10 to the 8 na Maxwell or lines, no? Convert lang natin. Meron tayong 10 to the 8 Maxwell over 1 Weber, na? Yan. So 2.5 to the 6 over 1/40 ay 1/4 ay ulitin natin, 2.5 times 10 to the 6 over 1/40 times 1/10 raised to 8, na? Meron tayong 1 volt, na? Ayan yung answer, na? Then sa number 5, when a generator is being driven at 1200 RPM, the generated EMF is 230 volts. What is the generated EMF if the field flux is decreased by 10% with the speed remains unchanged, no? Ibig sabihin doon, meron daw tayong speed na 1200 RPM. Okay? Meron din tayong generated voltage na 230 volts. What is the generated voltage, no? Meron daw yung generated voltage sa pangalawa. If the field flux is decreased by 10%, decreased by 10%, so magiging 0.9 na lang, no? Yung flux na pangalawa natin ay 0.9 of flux 1, no? Ay, ba't Q? Flux pala, flux 1. Then yung flux 1 natin ay flux 1, okay? Then ang sabi niya, with the speed remain unchanged. Kumbaga, yung N2 natin ay same 1200 RPM pa rin, no? Ano formula dyan? EG is equivalent to P zone, no, over 60A. So walang binanggit na pole, so constant. Walang binanggit na Z, so constant pa rin. Tanggal natin, tanggalin natin 60A, wala rin binanggit. Yung N, same lang din naman, so pwede natin i-cancel yan kasi parehas unchanged naman, no? Bale man titira na lang ay EG or generated EMF is equivalent to flux, no? So meron tayong EG1 over EG2, okay, is equivalent to flux ng una, tapos yung flux ng pangalawa, ito yung flux ng pangalawa, di ba? Flux ng pangalawa ay equal kay ito. Flux ng pangalawa ay equal dito. Yan. So, flux ng pangalawa ay equal dyan sa 0.9. So, magiging 230 volts over EG2 equals flux 1 over 0.9 ng flux 1. So, pwede natin i-cancel yung parehas flux, no? Then, EG2 is equivalent to 230 times 0.9. Meron tayong 207 volts. Ayan yung hinahanap. Okay? Next sample, number 6. No. A 4-pole lap winding motor with 16 slots, 42 conductors per slot, 480 volts, run at 1,800 RPM. Find the flux produced per pole. No? So meron tayong 4-pole. Lap daw siya. Wala siyang sinabi kung simplex, duplex. So assume natin simplex. Okay. Meron daw siyang 16 slots. O Z natin, di ba? Number of conductors or elements. Meron tayong 16 slots. Then, meron tayong 42 conductors per slot. So, para makuha natin yung number of conductors, multiply natin siya. 42 conductors per slot. So, matitira na lang dyan ay conductors. No? Meron daw tayong generated voltage na 480 volts. Okay? At meron daw tayong speed na 1,800 RPM. No? Ang formula natin dyan, EG is P zone over 60A. Pero yung A natin ay lap siya, so MP ang A natin, so walang sinabi, simplex lang siya. 1 multiply by number of poles 4. Meron tayong parallel paths na 4. Ha? Then, ito na. Pwede natin substitute yung mga value dito. Meron tayong EG na 480 volts. Okay. Meron tayong P na 4. Meron tayong Z na 16 times 42. Na? Tapos meron tayong yung flux hinahanap, no? Tapos meron tayong number of yung RPM, yung speed 1,800. Tapos meron tayong 60 multiply by 4. No? So, substitute lang natin yan, cross multiplication lang. Flux is equivalent to 480 multiplied by 60 times 4 over 4 times 16 times 42, 18. Or meron tayong 23.81 milli Weber na flux per pole, no? Ayun na yung hinahanap. Then, next problem natin. A 4-pole DC generator has a total of 600 conductors in its lap wound armature. The flux per pole is 10 to the 6 lines. Determine the generated EMF if it is driven at 2,400 RPM. No? Meron daw tayong 4 pole. Okay? Tapos, as a total conductors of 600, meron tayong Z na 600. Lap daw siya. Lap. The flux per pole, meron tayong flux per pole na 10 to the 6 lines, no? Pwede natin i-convert na sa Maxwell na, ay sa Weber, no? Times 1 Weber is equivalent to 10 to the 8 lines or Maxwell, no? Determine the generated EMF if it is driven at 2,400 RPM, no? Meron daw tayong RPM na 2,400. Hinanap si EG. So, ito na. EG is equivalent to P zone over 60 A. Pero si A ay lap, so meron tayong MP. A is equivalent to, wala siyang sinabi kung simplex, duplex. So, assume natin simplex, 1 times 4. Meron tayong 4 parallel paths, no? EG is equivalent to number of poles 4, okay, times Z natin ay 600. Meron tayong flux na 10 to the 6 lines times 1 Weber over 10 to the 8 lines, okay. Tapos meron tayong 2,400 RPM, okay, over 60 times 4. Meron tayong parallel paths, cancel si 4. Okay, ito 10. Ayan na lang. So meron tayong meron tayong 10 multiply by 10 to the 6 ay 10 to the 6 over 10 to the 8 multiply by 2, 4. Meron tayong generated voltage na 240 volts. Okay, next problem. A shunt generator delivers 195 ampere at a terminal voltage of 250 volts. The armature resistance and the shunt field resistance are 0.02 and 50 ohms. Respectively, the iron and the friction losses are equal to 950 watts. Find the commercial efficiency, mechanical and electrical efficiency of the generator, no? So pag nidrawing natin generator, ito siya, yung circuit, shunt lang naman. So ito. Okay. Shunt generator. Ito na. Okay. Then, ito na si RA, R shunt, na. Tapos meron na tayong terminal voltage na 250 volts. Tapos, meron na delivers na 195 ampere, no? So, meron tayong IL 195 amps. Sa RA natin ay 0.02 ohms. Dito, R shunt natin 50 ohms, no? Okay. So dapat pag dyan, isulat na natin agad yung power flow, no? Para din tayo malito. Ito na. P in, P out, no? P in, out, tapos SPL, PCU or copper losses. Then ito na si power generated, no? Ito si electrical efficiency, ito si mechanical efficiency, no? So para makuha natin si P out ay BL multiply by IL, no? 195 amps times 250, no? Okay, ayan na. 195 times 250 volts. Meron tayong 48.75 kilowatts, no? 48.75 kilowatts. Meron tayong P out na yan. Okay? Kunin natin si B shunt or ay si I shunt pala. Meron tayo ito si IA I shunt, no? So I shunt is equivalent to B shunt over R shunt. So meron tayong 250 over 50 ohms, okay? Meron tayong shunt current na 5 amps. Okay? Eh si IA natin ay equivalent kay I shunt plus line current, no? Meron tayong I shunt na 5 amps plus 195. Meron tayong armature current na 200 amps, no? Tapos kunin natin yung power ng mga mga resistor natin, kunin natin yung power, no? Meron tayong PA, no? Na IA squared RA or 200 squared multiplied by 0.02 PA. Okay, 200 squared times 0.02. Meron tayong 800 watts. Yan tayo, yan, okay. Then kunin natin yung P shunt natin, no? P shunt is equivalent to I shunt squared R shunt. So I shunt natin ay 5 squared multiply by 50. Meron tayong 1250 watts, na? Okay. Ano bang sabi dito? Meron pa daw siyang SPL na 950 watts. May given na pala tayong SPL na 950 watts. So, para makuha natin yung commercial efficiency natin ay ito. Commercial efficiency na P out over P in, na? Ito yun. Yung P out natin ay ito 48.75 times 10 raised to 3 over, di ba ang P out natin ay P in natin is equivalent kay SPL plus PCU plus P out, no? Meron tayong PCU na copper losses. Ito na PA, P shunt, sila lang yung may resistor natin, so ayun yung copper loss natin, no? Then may SPL na given 950, no? Ayun na yun. Tapos yung P out, so meron tayong 48.75 times 10 to 3 plus 1250 plus 800 plus 950. Ayun na yun. Times 100. Okay? So meron tayong commercial efficiency na okay, 48.75 times 10 to 3 over 8.75 times 10 to 3 plus 1250 plus 800 plus 950 times 100. Meron tayong 94.2% na commercial efficiency. Ayan na yung isa sa hinahanap, no? Ito, commercial efficiency. Meron tayo niyan, no? Mechanical efficiency, ito naman PG over Pin, no? Wala pa tayong power generated, no? So power generated is equivalent to EG IA. But si EG natin ay VA plus VL, where VA is IA RA. So meron tayong PG na ito, IARA natin. Ang IA natin ay, okay, ito na alam mo na natin. Yung VA natin, IARA 200 multiply by 0.02. Meron tayong voltage ng A 200 times 0.02. Meron tayong 4 volts. Okay, ito na. Meron tayong 4 plus yung VL natin na 250. Okay, ayan, EG yan, multiply by IA na 200. So meron tayong PG na 254 multiply by 200. Meron tayong 50,800 watts. Ito yung power generated, no? So para makuha natin si mechanical efficiency, meron tayong mechanical efficiency ay PG over Pin. Meron tayong PG na 4,800, no? Tapos meron tayong Pin na ito, Pin natin. Power input pala natin, di pa nasulat, no, kung ilan yung total, no? Power input 48,750 plus 1,250 plus 800 plus 950. Meron tayong 51,750 watts. Kaya yung Pin natin, no? So meron tayong mechanical efficiency 50,800 over, ayan, PG over Pin na ito 51,750 multiply by 100. Ilan to? 5,800 over 51,750 times 100. Ay, shucks, mali. 5,800 over 51,750, no? Times 100. Meron tayong 98.16% na mechanical efficiency. 98.16%. Then kay electrical efficiency natin ay P out over PG, no, times 100, no? Meron tayong P out na binigay. Ang P out natin ay ito, 48.75 o 48,750 na lang, no? Over PG natin na 50,800. Ito PG 50,800 times 100 ay equal kay 48,750 over 50,800, no, times 100. Meron tayo 95.96% efficiency. Ayun na. Next problem ay a DC generator as a mechanical efficiency of, meron daw tayong mechanical efficiency na 0.982. Tapos meron tayong electrical efficiency na 0.959, no? Ano daw yung commercial efficiency? Meron tayong formula na commercial efficiency is equivalent to electrical efficiency multiplied by mechanical efficiency. So 0.959 0.959 times 0.982, no? Times 100 mo lang yan. Kaya na yung commercial efficiency. 0.959 multiplied by 0.982 times 100. Meron tayong 94.17%. Okay. Next problem. Gets? Number 10 problem. Okay. A voltage of 100 kilowatts, 250 volts, shunt generator rises to 260 volts when the load is removed. What is the full load current does the machine deliver, and what is the percent regulation? No? So binigyan niya tayo ng load power na 100 kilowatts. Meron tayong load voltage na 250 volts. Okay, shunt generator rises to 260 volts when the load is removed. Oh, meron daw tayo na voltage no load na 260 volts. Okay? Aray ko. Tapos, ito na. Ang hinahanap daw dyan ay full load current. So, full load current, then the percent regulation, no? So, meron tayong PL is equivalent to BL/IL, no? Full load current is full load. Ito yung 250 volts, no? So, meron tayong 100,000 kilowatts, ay 100 kilowatts or 100,000 watts multiply by 250 volts multiply by IL. IL natin ay equivalent to 100,000 over 250. Meron tayong 400 amps. Ayan yung IL na hinahanap. Then yung voltage regulation natin, meron tayong voltage regulation sa generator na voltage no load minus voltage full load over voltage full load multiply by 100. So meron tayong voltage no load na 260 minus 250 over 250 times 100. Voltage na ang percent regulation natin ay 260 minus 250 divided by 250 times 100. Meron tayong 4% voltage regulation. Okay. Next problem. Problem number 11. Okay. A 230 volt shunt generator has an armature circuit resistance of 0.05 ohms and a shunt field resistance of 57.5 ohms. When the generator operates at rated voltage, it has a total core and mechanical losses of 1,880 watts. At what load does the generator operate to achieve its maximum efficiency? Na? Maximum efficiency daw. Okay, go. Then meron daw tayong 230 volts na ito, drawing mo natin generator. Meron daw tayong 230 volts eh. Shunt generator, so shunt, ganyan lang. Okay. Ito yung load. RA, R shunt. Okay, ito yung E, ito yung voltage load. Meron tayong 230 volts. Meron tayong 0.05 ohms. Meron tayong 57.5 na ohms na shunt, na. Meron daw tayong mechanical losses na SPL na 1,880 watts. Meron tayong formula at maximum efficiency. Okay. Meron tayong variable loss is equivalent to constant loss. Okay, yung variable loss natin ay IA squared, RA. Okay, is equivalent to constant loss natin ay yung SPL plus sa power sa shunt, no? Okay? Tapos ano ba ang hinahanap? What load generator operates to achieve its maximum efficiency? Ano daw yung sa load? Aray ko. Okay? Ito na, meron tayong IA prime kasi maximum efficiency siya para hindi lang tayo malito times RA SPL plus I shunt squared R shunt na. Makukuha natin yung I shunt sa B shunt is equivalent to I shunt multiply by R shunt na. Meron tayong 230, may I shunt tayo, tapos R shunt na 57.5 na. 230 divided by 57.5, meron tayong 4 amps. So IA prime, okay, squared. RA natin ay 0.05, SPL na 1880 plus I shunt na 4 squared, R shunt na 57.5. IA prime natin ay is equivalent to 1880 plus 4 squared multiplied by 57.5 na divided by 0.05, square root ng answer 236. Meron tayong 236.64 amps. Okay, then yung power na hinahanap ay PL is equivalent to BL tapos IL or I prime na lang natin na kasi maximum efficiency naman eh. So meron tayong BL na 230 multiply by IA prime na 236.64 no? Meron tayong power na answer multiply by 230 ay 2 teka lang mali pala, mali ito, mali. May nakalimutan. So, meron tayong IA prime, no? So, para makuha pala yun, si IL pala, I prime is equivalent to IL plus I shunt, no? So, meron tayong 236.64 is equal to IL plus, meron tayong 4 amps na, no? Then, IL 232.6 amps. Ayun IL, no? Then makuha natin si PL na BLIL 230 multiply by 232.6. Yan tayo, ha? 230 times 232.6. Meron tayong 53,498 watts. Okay. Ayun na. Final answer. Next problem. The output of a shunt generator is 24 kilowatts at a terminal voltage of 200 volts. Armature resistance 0.05 ohms. Shunt field resistance 40 ohms. If iron and friction losses equal the copper losses at this load, the output of the engine driving the generator is, okay, meron na tayong output, meron tayong generator, shunt.
Ha? Isang blue. Andiyan, hindi ko nga alam kung napatong eh. Andiyan.
Okay, ayun na. The output daw, meron daw tayong BL na 200 volts. Meron tayong load power na 24,000 watts. Okay. Meron tayong armature resistance sa 0.05. Ito yung RA. Meron tayong R shunt na 40 ohms. Okay. Tapos, meron daw tayong yung iron losses at saka copper losses ay equal, no? Meron tayong SPL tsaka PCU na equal, no? So, makuha natin yung ito na. PL is equivalent to BLIL, no? Meron tayong makuha natin si IL na 24,000 divided by 200. IL ay equivalent to meron tayong 120 amps, no? Tapos makuha natin si IA ay si I shunt pala muna. I shunt na B shunt over R shunt, no? 200 over 40. Meron tayong I shunt na 5 amps. IA is equivalent to IL plus I shunt. 120 plus 5. IA natin ay 125 amps. No? So, ito ulit yung ano natin, power flow. P in, P out, SPL, PCU, power generated, no? Ano ba hinahanap? Output engine, kumbaga yung power input, no? So, PCU o copper loss natin equivalent to PA plus P shunt, no? PA natin ay IA squared RA, no? IA squared RA plus I shunt squared R shunt. So meron tayong 125 squared 0.05. I shunt na 5 squared, R shunt na 40. Meron tayong PCU na 125 squared times 0.05 plus 25 multiplied by 40. Meron tayong 1781.25, no? Pero equal din siya kay SPL, no? So power input natin ay P out plus PCU plus SPL, no? Meron tayong P out plus SPL plus PCU. So meron tayong P out na 24,000 plus SPL na 1781.25. Tapos PCU na 1781.25. Meron tayong power input na 24,000 plus 1781.25 times lang pala. Okay. Meron tayong 27,562.5 watts. Okay. Next problem. Meron pa tayong last 5 problem, no? Medyo matagal-tagal pa. Pero kayang-kaya naman. Okay. Sabi, a shunt generator has an external characteristics whose terminal voltage given by the equation VT is equivalent to 250 minus 0.4 IL, where IL is the load current. What is the current and the power will be supplied by the machine to a load resistor of 5.85, no? Meron tayong load na BL is equivalent to IL RL, no? Pero i-formula, meron siyang given equation, yung BL or BT is equal lang yan, no? Equal yan sa 250 0.4 IL, no? So ano lang natin, substitute 250 minus 0.4 IL, no? IL Tapos meron tayong 5.85. IL natin ay 40 amps. No? Tapos yung power natin sa dito sa resistor, no? IL squared RA o RL, no? 40 amps squared multiply by 5.85. Meron tayong power na 9,360 watts. Okay? Okay? A short shunt compound generator delivers 150 amps at a terminal voltage is 230 volts. The shunt field current is 2.5 amps. The resistance of the armature series field and the diverter are 0.032, 0.015, and 0.03 ohms respectively. Calculate the electrical efficiency of the generator at its load, no? Meron doon tayong short shunt. Pag short shunt, sa right side yung RSC, no? Yan na. RA, R shunt, RSE. Okay. IL, IA, I shunt. Okay. Okay, ito na. So, sabi niya meron daw tayong IL na 150 amps. Meron tayong BT o BL na 230 volts, no? The shunt field is shunt field current pala. Shunt is 2.5 amperes. Then the resistance of the armature RA ay 0.032, series field RSE 0.015, and diverter 0.03. Calculate daw la electrical efficiency, no? Pag niroon natin yan, P in, P out, okay, PG, PCU, SPL. Ito yung hinahanap, no? P out over PG, power generated, na. So ito na. Kunin mo natin yung voltage drop sa BSE dito, voltage drop dyan, no? Meron tayong 150 multiply di pa pala pwede kasi divert. So pag sinabing divert, merong nakaparallel dito na resistor. So kailangan natin kunin yung R equivalent niyan, no? RSE multiply by R diverting, no? RSE plus R diverting 0.015 multiply by 0.03 over 0.015 plus 0.03, no? Is equivalent to 0.01 ohms, no? So ito pinag-isa na natin, so magiging 0.01 ohms lang siya, no? Okay, so bale ito magiging equivalent na pala, no? 0.01. Okay, the equivalent ay 150 times 0.01. Okay, meron tayong 1.5 volts. Yan, okay. Okay, para makuha natin si B shunt is equivalent to 230 volts plus 1.5. So meron tayong B shunt na 231.5 volts. Okay? Para makuha natin sa I shunt, 231.5 divided by R shunt natin na di na pala kailangan may I shunt na pala tayo. May I shunt na tayo na 2.5 amps. So kailangan lang natin ay R shunt. B shunt is equivalent to I shunt R shunt, no? R shunt natin ay 231.5 divided by 2.5. 231.5 divided by 2.5, 92.6 ohms. No? Meron tayo 92.6 ohms. Then kunin natin yung PCU, ay yung IA. IA is equivalent to IL plus I shunt. Meron tayong IL na 150 plus 2.5 na I shunt, no? Meron tayong IA na 162.5 ampere. So para makuha si PCU, okay, PCU ay equivalent to IARA PA plus P shunt plus P equivalent plus, okay, tama na pala yan, tama. Ito 162.5 squared times yung RA mo ay 0.032. Okay, P shunt na 2.5 squared times 92.6. Okay, plus P equivalent na 0.01 squared ay 0.01 multiply by 150 squared. Meron tayong PCU na 152.5 squared 0.032 plus 2.5 squared times 92.6 plus 0.01 times 150 squared, 1547.95 watts. Okay, so okay na. So para makuha si P out pala, P out ay 1547.95 plus 150 times 230. Okay, P out ay 150 times 230, 34,500 na watts. Okay, P out natin ay ito na 34,500 over 34,500 plus 1547.95. Electrical efficiency natin ay okay 34,500 over 34,500 over 34,500 plus 1547.95 times 100. Meron tayong 95.71% efficiency, electrical efficiency. Okay. Okay, problem number 15. A short shunt generator, a compound generator has the following as an armature series field and shunt field resistances are 0.04, 0.03 and 80 ohms respectively. The generator serves a 20 kilowatt 200 volts load through a feeder with an equivalent resistance of 0.1 ohms. Solve the power generated by armature, no? So number 15, meron doon tayong short shunt, no? No? Meron daw siyang BL na 200 volts. Meron tayong PL na 20 kilowatts. Meron daw tayong shunt armature na 0.04 RA. Series field na 0.03 RSE 0.03. Tapos meron daw tayong R shunt na 80 ohms. Meron daw tayong equivalent resistance sa feeder na. So meron daw tayong equivalent resistance dito na 0.1 ohms, no? Solve the power generated by the armature, no? So PL is equivalent to BLIL. Hinahanap ay power. So power input ang hinahanap, no? So meron tayong lang, hindi ba malabo, hindi kita may yan, meron tayong 20,000 multiplied by 200 times IL. IL is equivalent to 100 amps. Na meron tayong IA na IL line na 100 amps, no? Kasi itong dalawang to, equivalent ko na lang siya pag kasi series naman, so pag-add ko na lang 0.03 plus 0.1, meron tayong 0.13 ohms equivalent. Okay, so power flow ulit para may makita. Power out, P in, SPL. Okay, PCU, no? So yan na, aray ko. So ito, meron na equivalent, na. So meron ng voltage drop dito. So B equivalent is equivalent to R equivalent multiply by I line or line current, no? So 0.13 multiply by 100, B equivalent I times 100, 13 volts. Okay, 13 volts daw tayo dyan, no? So para makasi B shunt, BL plus B equivalent. So meron tayong 200 plus 13, meron tayong B shunt na 213 volts. Okay, ang pili. Okay, tapos ano susunod? Ay, so hindi pala, ano pala to, power generated by armature. So power PG pala hinanap natin dyan, PG, no? Power generated pala, mali ako kanina. So kunin na natin yung mga PCU, pero kunin mo natin yung I shunt, no? I shunt is equivalent to 213 over 80, 2.6625 amps. So meron tayong I shunt, meron tayong IA na lang kulang, IAI 2.6625 plus IL na 100. So IAI 102.6625 amps. So makuha na natin. Okay, PG, EG, IA. EG na lang kulang natin. Si EGI ito BA plus B shunt. Yan na. So ang BA natin ay 102.6625. Okay, multiply by 0.04. Okay. Plus B shunt natin na 213. Meron tayo EG na 102.26625 multiply by 0.04 plus 213. Meron tayong 217.1065 volts. So, ito na yan. 217.1065 multiply by IA. Ano si IA ko ay 102.6625. So, power generated ko ay 217.1065 times 102.6625. Yan tayong 22.29 kilowatts. Okay. Power generated.